Training your mind to prioritize speed and volume is a losing strategy. In a race toward mechanical precision, the human body has already been lapped. For decades, the formula for professional success was straightforward: acquire a specialized set of knowledge and execute tasks with high-frequency output. Yet today, highly trained professionals are trying to compete directly against algorithms on that same battlefield of execution, doubling down on the one metric where they are most vulnerable. There is a paradox at play. The harder you try to optimize your own workflow to match the reliability of a machine, the closer you get to making yourself irrelevant. Survival now requires a departure from the race for pure efficiency. The premium has shifted away from how fast you can do a task and toward your capacity for direction. The human brain was never engineered to be a flawless data processor. In the mid-20th century, economist Herbert Simon identified a concept called bounded rationality. It states that human decision-making is limited by a lack of time and finite cognitive capacity. This decision tree shows how we survive those limits. We rely on mental shortcuts, heuristics, to process complex environments quickly, turning overwhelming data into basic binary choices. This leads to satisficing, accepting a solution that is good enough to keep moving forward. To break through our bounded rationality and reach toward a standard of perfect optimization, we engineered artificial intelligence. We successfully built an unbounded execution engine. But we are now discovering that pure efficiency, operating without a human compass to guide it, carries a hidden cost. At its core, artificial intelligence is an execution engine devoid of intrinsic meaning or context. This graph visualizes Nick Bostrom's orthogonality thesis, proving an agent's intelligence and its ultimate purpose are independent variables. An AI can possess super-intelligent capabilities, plotted on the extreme right of the intelligence axis, while pursuing an absurd goal, like counting grains of sand. This leads to a principle known as instrumental convergence. An AI will acquire resources and optimize its environment to achieve its programmed objective, regardless of the consequences to the living world. The machine does not reflect on why it acts. It calculates the most efficient path to resolve the objective function it was given. While an AI can scale answers, it is incapable of asking whether it is solving a problem worth solving in the first place. That inability exposes the irreplaceable advantage of human cognition over machine logic. Psychologist Albert Bandura outlined this advantage through social cognitive theory, centering on a premise known as human agency. Unlike algorithms, humans possess intentionality and forethought. We have the ability to project into the future and weigh the ethical stakes of an action before we ever take a step. Our perceived cognitive flaws, the heuristics and emotions that make us inefficient, are the mechanisms we use to create meaning and decide what matters. Machines are designed to do things right. Only human agency is equipped to choose the right things to do. Power in this era is the product of two forces: the intention behind a move and the ability to carry it out. Because algorithms have commoditized the execution of tasks, your value depends entirely on how you apply your agency to the variables of intention and ethics. Simply following instructions makes you an operator, competing directly with automation. Integrators use AI to bridge human judgment and machine output, but the most valuable role is the director. They exercise agency to define problems, set guardrails, and dictate what the machine optimizes for. Directors never attempt to outcompute a machine. They treat intelligence as a utility to be deployed toward a purpose they have personally defined. In an age of infinite optimization, what matters is who holds the compass. Stop trying to outwork the machine. Learn to outdirect it.